Hello there. Today we're going to be going over an associative array or dictionary, depending on how you want to call it. These are data structures which are really useful in a variety of circumstances. First, I'm going to outline exactly what a dictionary is. Then I'm going to go into what this implementation looks like. And then I'll run through the code and some examples. So first off, what is a dictionary? It's a set of key value pairs, essentially. So you have a key, let's say it's someone's name, John, for example. And then you have a value, and in this case, let's just say that it's a struct. The struct has an age and maybe a date of birth would be better. But anyway, they've got an age and an address, something like this. Okay, pretty simple. And now we have a series of these. So we've got Sally, same thing, struct with an age and address, right? Now, when we want to look up a person's age or address, we can say something like dictionary get, and then we want to put in their name, John, right? And then grab their address. That's just an example using pseudocode. So this is basically what it is. So it's good for storing tons of different kinds of data, especially if you need to get that data back using some kind of key that you don't want to copy around everywhere. So let's say if this was an array and John was at position 0 and Sally was at position 1, right? So you want to get John's address somewhere else in your program, like in a completely different module or something like that, which has access to this dictionary. You'd have to know that John's index is 0, or you'd have to store it in a variable and pass it around, or store it globally. So this is kind of a nice way to get around that. All you have to pass around is the dictionary, or a reference to the dictionary, and then you can just use the key as a string to get the data that you need. So that's kind of why they're nice. They're pretty flexible in that way. So the implementation that we're going to be looking at today goes something like this. We have something called a dictionary item, which is defined as such. We've got a key in here, which is a character array. Well, actually, it's a pointer. Wow, that's a horrible asterisk. Alright, so this is our key. Then we've got a void pointer, which is our value. Then we've got a dictionary item, pointer, next. Alright. So this is going to come in a second after I explain the first part. So our dictionary is basically a set of these things called buckets, right? So let's say we've got 4 buckets. Okay, each one of these buckets is actually a dictionary item. Okay, they're all going to be empty by default. And the amount that you have in this instance is going to be defined by the programmer. So you call dictionary new, then you'll put in here the amount of buckets that you want. So in this case 4, then the size. So we're just going to use, I guess we'll use this example up here. We can say size of, and then I don't know what this is called. Let's just call it info. It's an info struct. Anyway, this is kind of pseudocode, so it doesn't really matter. So we're going to create 4 of these buckets. So why would you want a limited amount of buckets? The reason is because every time you add someone to the dictionary, this string gets converted into an integer. So let's just say, for instance, John gets converted into 0, Sally gets converted into 1, and then let's say we've got Bob, right? And Bob also gets converted into 1. that's going to be a problem because we want to put John in 0 and Sally in 1, and then we also want to put Bob in 1, but we can't do that. So what we do is we have already put Sally in 1, so her dictionary item is filled out here. So we've got Sally, right? And then we've got this next pointer. So we're just going to create another dictionary item, and we're going to point to it. And this is where Bob is going to live. There we go. And he's going to have a next pointer as well. So it's a sequence of linked lists, essentially. Each one of these buckets is a linked list, or the beginning of a linked list, right? So we might as well put John in here. Anytime there's a name collision, which is what this is called, or a hash collision, then we will add a new chain to the linked list. So what does that mean? If you want to add maybe 1,000 different, more than 1,000 things, then, and you know that you want to add more than 1,000 things, or around 1,000, then you can just make your dictionary 1,000, right? And it will take up more initial memory, but since you know you're going to be filling all of these slots anyway, probably, then it'll be more efficient. Whereas if you don't really know how much space you're going to take up, you know, maybe it's not going to be that much, you can make it smaller, and then the chance that you'll have a linked list is higher. But it really depends on what you're going for. So the trade-off that you make is when you look up someone like John, who has an address of 0, you can just get that right away. You don't have to look down a list to find him and compare keys and such. So that's pretty much how it works. I'm just going to put another person here, and they're going to be Ghost for some reason. Alright, so what happens when you remove someone? Let's say we get rid of Bob. Bob gets removed here, right? And then this just points to Ghost. Well, actually, the implementation is a little bit different. In the implementation, Bob's pointers actually get pointed to here, and then this one gets freed, and Ghost basically moves up here. So it's a little bit different, but essentially the same idea. So usually I would want to type out everything with you guys, line by line, and explain everything, but unfortunately, for reasons I'll get into at the end of the video, I can't do that this time. So instead, we're just going to move over to the code that I've already written, and don't worry, this will be linked in the description on my GitHub, in case you want to have a look at it. So, here we have the header file, and I actually had this as an opaque type earlier, which is why this is left over, but I'll remove that. Here we've got the dictionary. Very simple. These are the buckets I was talking about. And then this is the size, and the size is the size of whatever value you want to store. So if you want to store integers, you do size of int. If you want to store some kind of structure, you do size of, and then the structure type that you want to store. And then the max length is the amount of buckets that you start with, or that you have, right? Dictionary item, just as I said earlier, key value and next. And these are the functions that are available. We've got new, which is how you create a dictionary, and we've got set, which is changing a value or setting a value. If the value doesn't exist, it'll be created. If it does exist, it'll be overwritten. And we've got get, which just returns a void pointer to the value. So you need to know what value it is that you put in when you get it out, so you can do something with it, as you do all the time with void pointers. Now we've got remove, rm, which is it just removes one of the values. And then we've got free, which is how you destroy the whole thing so that it doesn't take up any more space in memory if you've stopped using it for some reason. That's it. Alright, now let's have a look at the actual code. Yeah, blah, blah, blah. The implementation, I don't think is really that important. So let's have a look at some tests, right? What have we got? So on the right-hand side here, we've got a bunch of fruits and some values. All right, so I'm going to actually run this through a debugger. Where is it? Here it is. All right, here we are. So let's put a breakpoint here after we've set up all these values: apple, orange, grape, cherry, and banana. You can have a look here. So we've got 3 buckets in our example. And the reason that I put such a tiny amount of buckets is because I wanted collisions, because it's good to be able to test that everything works correctly. So we've actually got 3 collisions on the index 0. Apple, grape, and cherry are all taking up the same bucket. Or rather, they're in the same linked list. And then in buckets index 1, we've actually got nothing. There's nothing here. And then in 2, we've got orange and banana. So we can see that worked. So let's continue on. So we've now set the value of grape to something else. So you can see grape was 70, and now it should be 54. As soon as we move to the next, there we go, grape 54. You can see down the bottom left it's printed out. Now we're just testing removing. So we're going to remove banana. So this is removing from the end, testing that. There we go. Now remove from the beginning is orange, right here in bucket 2. Continue. Now we're going to try removing from the middle, and that's up here. So grape is in between apple and cherry. So look, there we go. And we just want to make sure that all of these things are zeroed out. So there's no pointers left around, and there it doesn't seem to be. Great, and now free the whole dictionary. Now we're going to add some drinks. So we've got whiskey, and we've got coffee, and we've got beer. And you can see I'm adding whiskey using whiskey.name. And this is the value of that. It's 32 characters, whiskey, and then 00000. And coffee I'm actually adding by actually typing this string out. Right, so you can do it either way in this case, because the structure that we've defined for drink is up here. We've got name, price, and the mils. Let's just have a look at that. Continue on. So whiskey has been set in here in bucket 1. Now we'll go down to here. So we've got beer and coffee. Everything's working, and now we've printed whiskey is $16, and it's 40 mils. Coffee is $5 and 350 mils. And finally, beer, $9, 425 mils. Cool. In the future, we're going to be using dictionaries in the game engine series. I'm not sure if it'll be this implementation. I might do something else. So next week, we're going to explore a different dictionary implementation. We're going to be using a binary search tree instead of this list of linked lists. So if that seems interesting, make sure you subscribe, because that'll be out next Wednesday. On Sunday, there's going to be another engine video, so make sure you tune in for that if you're interested. And that'll be beginning the coding, so that's pretty fun. Make sure to leave a like if you found this informative, and hello, it's me from the future. While I was editing this video, I realized I was going to say why I couldn't code with you guys, and it's because I got a new keyboard, and it's kind of like hold it up here, it's like a split keyboard, so there's 2 of these, and then because I had to learn how to use a split keyboard and it's all different, I thought maybe I should also try and learn Colmac. So I don't know if you can see, but it's wildly different to QWERTY. So my typing speed right now is absolutely horrendous. It's only been maybe 3 days, and the first 2 days were absolutely horrible. It was painful, really, really painful. But, you know, I'm going for those long-term gains, so hopefully that works out. Anyway, catch it.